I'm Carl Dessence, and Larry Rambo is with us as well. And we're going to talk about some tips to keep your fleet batteries maintained and properly charged. That way you get the longest and best life out of these things. So here's what we want to cover today. We want to cover battery terms, how that battery is built. We want to look at inspection of the battery, testing, and then cover a battery recharge area, an area that you can reclaim batteries and save yourself a little more money with your fleet. All right, so first let's talk about terms. And voltage is the biggie. That's the push that pushes everything through. So this is our electrical pressure or force that causes our current or electrons to flow. Without it, you've got nothing. So an open circuit, there's no voltage. The closed circuit, you see voltage there to the load. The voltage is the difference in pressure between 2 points in a circuit. And obviously it is measured in volts. So current or amperage, that is the flow or the movement of the electrons. You know, you can compare this to the flow of water through a pipe, how much water went through there. But without voltage or pressure, that current's not going to flow. So electrical current is measured in amperes or amps is what we use. Now, there's some battery ratings that we need to be aware of as well. One of the biggies is cold cranking amps, or CCA, and that's the number of amps a battery at 0 degrees can deliver for 30 seconds and still maintain a voltage equal or higher to than 1.2 volts per cell. And in this case, most 12-volt batteries, we have 6 cells or 6 elements. So it's going, bottom line, it's got to be above 7.2 volts. Then we have reserve capacity, and that's a rating that allows the battery capabilities for sustaining a discharge to be compared. So the definition of it is the number of minutes which a new fully charged battery at 80 degrees can be continuously discharged at 25 amps and still maintain a terminal voltage equal to or higher than 1.75 volts. Notice this is higher. So once again, the 1.75 times 6 cells or elements. And this one, I'm looking at 10.5 volts. And you've got to understand the cold cranking versus reserve capacity, because that does change and does affect how things operate. All right, so let's look at the first polling question we have. And what value is more important to the quality of a battery? Is it CCA? Is it CA, reserve capacity, or it depends on the application? And if you'll go ahead and click on one of those and submit your response, we'll look at what we see here in just a few minutes. Have some coming in. Still see a few. All right, let's look at what we've got. So CCA, we're good there. Reserve capacity, you guys are awesome in the fact that you know cranking amps isn't. And yes, it does depend on the application, which is more important for cold cranks or reserve capacity. You're talking about a truck, you want to know cold cranking amperage. When you're looking at liftgate batteries and some of those things, that reserve capacity is a little bit more important. All right, Larry, you want to talk about how we're building a battery these days?
Yeah, thank you very much, Carl. And again, I'm Larry Rambo. A lot of you know me. Been with the company for a few years now. So, but yeah, we're going to talk about building a battery. I think it's important that people just understand what a battery is. A lot of times people think it's just a magic black box that makes electricity or something. But, you know, first thing we take a example of the most basic battery there is out there, and it's all any battery is two dissimilar metals in an acid solution. So if you want to make a very, very basic battery, you take a lemon, a nickel, and a penny. You have two dissimilar metals. You can solder wires on the nickel and penny, cut two little slots in the lemon, and you can power a little digital watch. Kids will think you're the greatest, on the planet. Don't tell them any different. They'll realize you're not later. But again, it is a very basic battery, and that's no different really than an automotive, battery we're going to talk about. That again, you have two dissimilar metals. That the positive is lead dioxide, the negative is sponge lead. Even though they're both lead, chemically they're different different metals. And those two different metals are now sitting in a acid solution, which is electrolyte. Electrolyte is made up of 64% water, 36% sulfuric acid. They make electrolyte. When that battery is at 100% state of charge, it has a specific gravity of 1.270. When you use a hydrometer, that's all you're doing is checking the specific gravity. Hardly anyone uses those anymore, but whether you're checking, antifreeze or a battery, same principle. It's a density of that electrolyte compared to water. So we take that battery and we put a load on it. As you discharge that battery, you're actually taking and driving the acid into those plates. So as that battery discharges, those plates will actually swell because the acid's being driven into them. So you keep discharging. You take that battery all the way down to basically water because you've driven all the acid into those plates. At this point, you have two similar metals in a water solution. Now, the neat thing about a lead acid battery compared to the lemon is, what can we do with a lead acid battery? We can actually recharge it, and when we do that, we actually are driving that acid back out of the plates. Keep charging, get it back up to 100%, and now we are back to two dissimilar metals in an acid solution. So depending upon state of charge of that battery, how much you discharge or recharge it is going to impact, what is the strength of that electrolyte, and goes with the voltage and state of charge. Now, yes, basically we drove all the acid in the plates and we have water left. Do not try to drink it. It is still acid. It is still corrosive, still bad. So you got to be careful. But again, that's how that battery operates. That one thing to talk about too is when we talk about batteries, there is ampere hours, and all batteries have a fixed amount of energy to them. Whether it's a cordless tool battery or a lead acid battery, they all have a certain amount of power they hold. And at times, technicians are very bad about blaming technicians or blaming drivers, because if they have a dead battery in their truck, they ask the driver, what'd you leave on? Nothing. Well, in their defense, they may not realize what they did. And to understand that, you have to understand ampere hours. If you have a 1 amp load and you leave it on for 1 hour, you've taken 1 ampere hour out of that battery pack. Most trucks have 3 or 4 batteries in them. Each battery is roughly 100 ampere hours of energy. So if you got 4 batteries and you got 100%, new batteries, you have 400 ampere hours of available energy there. As they age, as they, cycle, they're going to lose capacity. But I'm going to say for right now, easy math, 400. If you have a 10 amp load and it's on for 1 hour, now you've taken 10 ampere hours out. Swap it around, 1 amp, 10 hours, still 10 ampere hours. If it's a 10 amp load in 10 hours, that's a total of 100 ampere hours. So if we look at that, we got a little quiz for you here. Which would discharge the battery more? First one is starting an engine 10 times. Second one is the driver leaves his refrigerator on for the weekend. Third one is lights left on during delivery. Give you a chance to answer on that one. Got a couple coming in finally. And if you're not familiar with this, just, click the A, B, or C and it'll submit it for you. And I apologize for the background noise, and why I'm not on camera is I'm actually doing this remotely. So I'm actually in Florida and it's getting a little warm in here. So I have to start the truck back up. All right, we got 54% of you. So 19% said starting the engine, 61% for refrigerator, and 19% for lights on. Give you the math here. You didn't realize you get to have math today. But starting the engine 10 times, yes, it's a lot of current, but it's a very short period of time each time. So actually, you're not taking very much out of those batteries. The refrigerator, which I think majority of the people answered, which is correct, 72 hours times 4 amps, that's 288 ampere hours out of that 400. That truck's not going to start. Now, we probably shouldn't have used refrigerator because that's the one we always find the driver left on. And the last one's is lights. Kind of in between. It's a little bit higher load, but not nearly as long. And one of those things that I always tell people is it doesn't matter if you get shot by a cannon or shot by a BB gun. If you die, you die. It doesn't matter, well, it's only a small load. If you leave it on long enough, it is going to be dead. And this is where I also say, we always pick on drivers because, they didn't realize what they left on. They killed the batteries. Technicians sometimes are just as bad because they take the roll around charger, go over there and hook up to a truck, put it on fast cook for 45 minutes and think they charge the batteries. Even if it's an 80 amp charger and you only left it on for 45 minutes, you only put 60 ampere hours at best back into those 4 batteries. So did you really charge them? No. So again, it's important to understand, and this goes back to what Carl was talking about, reserve capacity is, the more reserve capacity, the better those batteries can handle that type of cycling and not only, still be able to crank the engine, but also have a good service life. And just, again, kind of graphed out those levels of discharge. All right, I'll turn it back over to Carl.
All right, thank you, Larry. Now let's talk a little bit about inspection of that battery, because before we start doing maintenance while it's in the vehicle, we need to look at it, look for some things that might be related to cause issues. One of the things is a cracked case. That's one, depending on the type of battery, if it's a lead acid battery, you're going to leak fluid out. You have a fluid leak. If it's one of the newer AGM batteries, I don't see the fluid leak, but I do have internal damage to that case and that battery. So we got to look for any cracks that may be there. Also loose hold downs. I know talking to some of these sales guys and people that are out in the field, they find a lot of loose hold downs. And I could tell you from experience that these batteries are jumping around in there going down the road. So you want to keep them as still and as anchored as you possibly can. That way you don't lose all that lead paste that's on those grids for each cell. Dirty case, that's another thing that you don't realize, that dirt on top of it actually can have a case draw, and that could be another thing that will draw the battery down over time. And then obviously we want loose or damaged post, and a loose post you don't always find with that nut in place. So you've got to pay attention and watch those things. And we've got a slide coming up here that shows us that. Another thing you need to look at, some of the batteries still have the built-in hydrometer in there, or the eye. And what you want to do is look on that. That's going to give you a fairly decent indication of the condition of your battery. So if you're looking at one that's fully charged, you actually see that ball is up inside that view, and you see a green, a little green light, little green dot there. Once that ball falls out and that battery starts being discharged, then you're going to see that ball will go away and you're going to see a little black dot. And then when you have low electrolyte, that's clear. And at that point, don't test your battery. That's a do not pass go, or as I used to say, do not collect $200. You're not going past go on a Monopoly board. You want to get that battery out of there because it's dead. So that's the big thing with that eye that we want to pay attention to. When we're looking at these posts, obviously the one on the left you see looks like it's a little stripped, it's been loose. You want to make sure that if you find those like that, get those out of there. At the same time, you see a little bit of dirt and corrosion on the one on the right. Corrosion is just as bad as the case being dirty and all those things. Definitely want to clean that off because that creates resistance. Resistance can create heat in that wiring, so it's a good indication. If I've got some resistance, that wire and that connection might be getting a little hot. So clean that. There's tools out there. Wire brushes is your best bet. We've got some that go on drills, some that you can use just a wire brush over it. But get that contact area between the battery cable and the battery. You want them clean on both sides. So let's look a little bit on starting on our testing, okay? So the first thing is, obviously we want to look at our battery cables. One, are they corroded? Where are they at? If we're going to test batteries, we want to take the cables loose, test your batteries individually. And at that point, that's a good time to go ahead and clean everything. You're not going to get a true indication of how that battery is and the life of it if you don't have the batteries, the cables off of it, and these adapters, because that stud can be loose in, and that stud actually just screws into that lead pad. So you got to be on the lead pad, and that's where our little battery adapters come in. That lead battery, or the battery adapter, is going to screw down to the lead pad and give you a true indication of the condition of the battery. Obviously, if we have a loose post, we're not going to do that well. Plus, I don't have a good connection. When you're load testing a battery and you see smoke, it's not good. Your connection is weak. You need to stop and go to the next level. Try to reset it. We do have several different test equipment. There's different variations out there. Some of them are electronic, some of them are still, manual. You apply the load. The thing is, use a quality piece of equipment. And one of the things that does is my battery voltage is going to be greater than 12.5, and this is what we call open circuit voltage, or OCV. If it's over 12.75, that means we've got to remove any surface charge that's there. So we're going to apply a 300 amp load for 15 seconds. And some of the electronic equipment, and this is the auto meters, the BVA 2100 or the BCT 200, they do it automatically. Manual equipment, your good old carbon pile or the BVA 36, you're going to have to do that manually. So you're going to have it. A lot of those have a button on there with a timer, so you'll be able to use that. When we're looking at our electronic equipment, that tester requires you to enter what the rated CCA of the battery and the estimated temperature of the battery. Now, we're talking about the battery. The best way, if you do have a thermometer or an infrared thermometer, check the case. Because obviously, if I just pull it in from outside and it's 32 degrees there and I'm 65 in the shop, that battery's not going to be 65 degrees. It's going to take 4 or 5 hours or more before it's even going to be the same temperature as what's inside the shop itself. So the tester at that point, it automatically calculates everything what my results should be. In other words, when it starts giving me readings of the condition of it, how good it is, how bad it is, it's already taken all that into account. So if I'm using the manual equipment, I have to use half of the rated CCA for 15 seconds. So if most of them, if you're out there and you got a 750 cold cranking amp or CCA battery, that means you're going to apply that 330 roughly, or 325, excuse me, for 30 seconds. Now I'm all messed up. 750, 320 or 375, apply it for 15 seconds, and you're looking at what that voltage reading at the end of the test is compared to the chart that we're going to show you here. So we know at the end of a test, and I'm looking, usually when we test these is about this time of year. So a lot of times now I'm down in the 60-degree range. At the end of 15 seconds, my battery's got to be at least 9.5 or higher for that battery to be good. If it's lower than that, probably need to pull it out and charge it. Or, as Larry said, a quick, fast charge isn't going to get there, because you do have to get to that last level of charging. It takes a little longer to get you back to close to that 100%. So that one thing to pay attention to here when you're looking at that. Temperature chart, there's another thing. So if I'm looking at about an 80-degree day, 80 degrees, that engine takes 100% of that battery power that it can produce to turn it over and get it started. When my temperature starts dropping, obviously because of the physics, and I'm looking at dissimilar metals, and my liquid inside there, my oil, gets a little bit thicker, it starts to take more. So down at 32 degrees, that engine's taking 165% now to turn it over, and yet my battery only has 85% of the charge that I would at 80 degrees. When I get down to zero, you're looking at 250%, and I'm looking at 65%. So now I'm almost half of what that battery is actually capable of in cold cranking amps when I'm going down the road, or when I start at 80 degrees. Larry, you got anything else to add on that part?
No. If you don't leave yourself muted. But no, you covered everything very well. Some of the things you didn't really cover that, just made to bring up is some of the new electronic testing. As far as like battery bank testing, that battery bank testing has its place. That is a very good test, in my opinion, in between services, or if you have a write-up for an electrical issue. I think a lot of fleets miss the boat anymore. I'm old school, that I always like to see batteries get taken apart and tested twice a year. We talk about, we do webinars for, get your fleet ready for winter, or get your fleet ready for summer. Those are the two big times, is fall and spring, that you need to do those tests. Is, do the load test, take everything apart and clean it. I see a lot of fleets and go to a lot of locations, and you open up the battery box and I swear you could grow corn on top of them. They're so dirty. That, as Carl mentioned before too, about batteries self-discharging through all that. So, everything needs to be taken apart and clean, wire brush, the whole bright and tight. One thing is I actually swapped out a picture on this presentation I used to use, and I feel bad I didn't leave it in there, is if you've got some of the OEMs use the daisy chain battery cables when the batteries were between the frame rails. Everybody wants to take the 4 battery nuts off and flip the cables to the side and do the battery tests. I said, well, what about where those 2 main cables, connect the middle? Well, I'm scared to take them apart. Usually when I do, they break. Well, it's like, that's telling you something, that you got to take all those things apart and clean them. Same thing too is, a lot of manufacturers will connect different power sources to the batteries. Whether it's an ECU, power and ground, all those got to be cleaned in the process. The one last thing I also want to comment on is battery protectant is a wonderful thing. If you use the right battery, you're not getting corrosion from the batteries. But if you look at the chemical cocktail that, trucks ride in anymore, every state uses a different means for, snow and ice. If you got a truck that goes through 6 different states, look at how many different chemicals are all over in there. So battery protectant's important. But one of the biggest things I always stress to people is you take everything apart, you clean it, you do your testing. put it back together, then apply it. All you're trying to do is protect that bare metal from corrosion, and use it sparingly. I've had some where I went back to do some testing. Took me 30 shop towels just to get all the gunk off them because of how much they put on there. And one thing to stress about it too is put it on afterwards. All those sprays are an insulator. I saw somebody put a big blob of grease on the battery post, then put the cable on top. And so, why didn't you put some plastic washers on there too? I was like, well, what do you mean? I said, well, even though it's quote unquote dielectric grease, it's still an insulator. It's not designed to help conduct. It's a protectant to protect it, not to help conductivity. That was a very long response for you, wasn't it, Carl?
It's good because there's things that we all miss as we start talking about these things.
Oh, yeah, that's one of those things. You could talk 3 hours on a webinar about batteries. So we tried to somewhat consolidate it and cover a bunch of different areas, which kind of segues into our next spot, which is a recharge area. Batteries are very expensive. You don't want to waste them and throw them away just simply because they're discharged. There is nothing wrong with having recharge batteries if they go through the right procedures. That's, sorting, testing, charging, all those things together. And one of the biggest things I always tell fleets if they're going to do a battery recharge area is the old adage that too many cooks spoil the stew, that you need to have one person assigned to it. Somebody's got to watch and make sure they went through that process properly. So this next session, we're going to talk about that. This was, one customer's, quote unquote battery recharge area. That's, you have to make sure you match it for your size of your fleet. If you've got, this many used batteries, there's a problem somewhere. You need more capacity, more people, more chargers, or whatever to make it work. So hopefully no one ever has a pile like that. But recharge batteries are just a ton of money. It's one of the under tires, probably the most common, highest dollar cost for a fleet. And when we say a recharge area, recharge program, it's got to have a flow. You got to have some method behind it all, so you know what you're putting in, what you're doing. Excuse me. And I will say, pallets. Depending upon the size shop, the size fleet, it may be shelves, it may be tables, it may be pallets, whatever. But the most important one is your starting one. That is where if any technician, whether it's Tech A, B, C, Fred, Jim, whoever, if someone takes batteries out of a truck because they were deemed discharged, defective, whatever, that's the one place he puts them. That's the only time he steps foot into that room is when he puts them on that pallet. For the person in the battery room, that's where they have to start too, is, look at them. Again, like Carl was talking about before, the physical inspection. If the battery's damaged because someone is using impacts, would have been a good poll question today is what's the torque on a battery nut? It's only 10 to 15 foot-pounds. I don't care how worn out your, import impact is or whatever, you're going to damage batteries. All that stud is a 3/8 bolt that was cast in the lead, and if you start hammering on them, you're going to break them loose. I was at a fleet one time, you could actually see the hex head because they've over-tightened them so much, it was pulling the bolt head up through the pad. When that happens, that battery's junk. So again, the inspection. Age of battery. You look through them and says, hey, I don't care how good this battery is. It's so damn old, I don't even want it for a doorstop. Or, again, to sort for your warranty stuff. The other thing's manufacturer. Is that an approved battery for your fleet? Is it something you picked up at Billy Bob's Road Surface that you have no idea, who they're actually made by? They're a weird rating, any of those things. And we may not throw them away yet, but we need to be aware of what we're going to do with them. So we clean everything up, wire brush, install our adapters, and we can run through them and actually charge them. There's many different chargers out there. I do highly recommend automated chargers. When I say automated, you hook them up, the charger kicks on, charges the battery. If it detects something's wrong with the battery, it shuts off. If it gets to 100%, it goes into a float mode, but you don't have to worry about overcharging batteries, things like that. When I first started doing this years ago, most fleets use big bank bus bars, and you had a 100 amp charger that could do 12 batteries or whatever. The problem was if you had one battery that had a shorted cell, all the other batteries would discharge into that one, and shop started to smell like rotten eggs. And the bad thing was the other 11 batteries or 10 or however many were hooked up didn't receive anything because they're also all discharging that one defective battery. So again, automated chargers make things much easier. Most of them have a red light, green light, so you can look across the room and says, hey, I got 2 that are charged. I can go ahead and swap those out, put 2 more in place, and keep going. So you went through all the procedures, you've charged them. Now we can actually test them. Excuse me. But here's one of the biggest keys where people get a bad taste in their mouth from recharge batteries is, one, again, you got to test it just like you would if it was in a truck, whether it's using a carbon pile or whatever. If it fails, we're going to talk about that pallet in a minute, but if it does pass, we're not done yet. It went through the initial test. We're going to put that battery on the side, hold it for at least 24 hours, and do a re-test on it. We found you'll lose about 10% of your batteries where they have a very low-grade short in them. And when they're fresh off the charger, they'll pass. When they sit there for a while, suddenly the battery's no good. And that's, again, where people get a bad taste is, we tried to recharge and we kept having problems. Well, again, you didn't do all the right steps. Oops. So went through that. Now that's our 24-hour hold. We're going to, again, test just like we did before. Still separating based on the outcome of that. If it fails, if it's in warranty, we're going to put it on our warranty pallet. If it fails and it's not in warranty, we're going to put it on our scrap pallet. One of the things, too, when we talk about warranty batteries is, I don't trust anybody further than I can throw them. So if you put 10, warranty batteries over there and they're within warranty or whatever, whenever your battery guy comes up, you need to make sure it says, hey, I got 10. You owe me 10 batteries, or at least next week when you bring me, batteries again, you owe me an answer. But you need to track it. Don't trust anybody. Well, he grabbed what was ever there, and you hope you get your replacements. Not sure how, each fleet's warranty is set up, but you do need to make sure you hold people accountable for it. So again, retest. And one of the other things is make sure you mark everything. That's the nice thing about a lot of the electronic testers too is they do printouts. So if your tech did test the battery and said it's bad, you should be able to compare it. Did that technician properly test that battery? One thing I found is, at times techs don't always understand the tester properly. They weren't properly trained, or they may take some shortcuts. But if you look at a printout and said he just tested it 2 days ago, and you look and the printout says it was tested at 70 degrees, it's like, well, where was he at? It hasn't been 70 degrees here in 2 months. So did he do a fair test on that battery? Probably not. When you get your pallet, everything that has been charged, now you got to go back through it again. It says, hey, they are good batteries. Now what am I going to do with them, though? Hey, this is the battery we use. It's the right model, the right CCA. You look at the age of it and says, hey, this thing's 2 years old, whatever. It's worthy of going back into, one of our trucks. May look at it and says, yeah, it's a good battery, but it's 5 years old. Or it may be, again, that oddball battery you picked up somewhere on the road. Do you want to put it in your truck? That's what we call trade truck batteries. That you got a truck that's getting ready to go out of service or whatever, needs batteries. Don't put 4 brand new expensive batteries in there. There's 4 good recharges that are fine for it. But the other thing I highly recommend on this pallet too is you put together batteries as sets. These are the 4 same manufacturer, same model. Look at the age, says, hey, they're, our rule of thumb's always been within 6 months. So it's a fairly good match set of batteries. If you don't, have 4 different oddballs in there, guess what you're going to wind up doing with that truck 3 months from now? It's going to have a battery problem again. So you need to make sure you keep them matched up. And this was gone through fairly quickly, but there are many steps to a recharge program, but if you do them correctly, there is nothing wrong with using recharge batteries, and it can save you a ton of money. One of the things I also tell people they ought to do as well is assign a different part number to your recharge batteries. That way you can see, track how much you're spending on new batteries, how much you're saving on recharges. So different part number, keep track of them, see where you are. And we did just have a question come in. Carl, you want to take that one?
Sure. Question is, can you mix AGM and lead acid batteries in the same truck? And it is not recommended. Little different discharge rates, little different charge rates. So you're not going to keep your batteries in a good condition if you do mix the two. You got anything to add there, Larry?
Road, you can do it, but long term it is not a good practice to ever do.
Yeah.
The problem is fleets are very common or very familiar with doing that second step. Hey, we did it. We got the truck off the side of the road or whatever. They don't always remember to get it back in and get that changed.
Well, and the other thing, another thing about recharge batteries is it's a good way of getting your equipment back on the road when you've got a set. Because you can take a bad set out, put a good set in, even if it's recharged, and that truck can go on and start making money hauling that freight.
Yeah, it's especially important in wintertime that, batteries are like me. They don't like to work when they're cold. So you can very easily have batteries that are simply discharged because, again, that driver left something on. Batteries, discharged. You're not going to charge them quickly at all when they're that cold. They just don't want to take any current. So you're going to let a truck sit there for 2 days while you charge the batteries and everything? No. You pull them, let those batteries warm up, and it's a great set for when another driver did the same thing. And that was the last one, so it's a perfect time for questions. I do ask that no matter what, quote unquote, the presentation's over, still have some questions coming in, but please ask that you don't leave until we wrap up, because there is survey questions at the end, just as a follow-up to today's presentation, and also suggestions for future webinars. We do this as a service to you as our customers. So if you have suggestions, ideas, things that we can help you with, please let us know.
Larry, we got another question that came in. Is there a preference really between a carbon pile or automated tester?
Yes, there is. And when I, again, first started doing all this, and same with you, because we're about Ike and Mike in years in the trucking industry. But before, that's what I cut my teeth on, was an old SB5 carbon pile. And that was the ones you talked about before, where you had to manually crank them down. You took the rated CCA, you held for 15 seconds, you looked at the voltage at the end. If you did it right, you had to go back to that chart that you talked about and look at what that minimum was at that temperature. A lot of technicians never did that. So did they always do a fair test? Also, too, sometimes they didn't do the right math. And if you didn't apply the correct load, you didn't do a fair test, you could fail a good battery or condemn a perfectly good one. It was very user sensitive. The other thing that was bad about, or is bad about, a carbon pile is the only thing they check for is, can that battery give a burst of energy or a crank? And a lot of times people have this happen on their personal vehicle. Crank's fine every day. The one day they go out to the lake and they leave the key on, they're listening to the radio, 20 minutes later, it's hammer dead. Did that battery just now fail? No. It always gave that, had that ability to give you that one quick burst. It just had no capacity left. And that's where the electronic testers or the automated testers now shine. because not only they do a load on the battery, but they also look at active plate material, and they can give you a lot more information about the health of that battery. So the automated ones have come a long way and do some incredible things for us. So yeah, I would always, at this point say, yes, you want an automated electronic type tester.
Well, another thing on the automated tester is, regardless of how the age or the tech or the experience, you're going to get some consistent results. So whether the guy's been working 20, 30 years or the guy's just started and doesn't know all those steps to use that carbon pile, I've got the same results. So I've got a better electrical system because of it.
Yeah, I actually had a guy tell me one time, he says, you've made my tech stupid. I said, well, what do you mean by that? He goes, you've made it all automated and all these things. They don't have to know anything. It's like, our goal was never to make the technician, quote unquote, stupid, but it was to be the equalizer, to make that new hire guy just as good as the one that has been doing it for 20 years.
Yeah.
One other question that always comes up on this is, can you set a battery on concrete?
That's always a good one.
And the thing is, yes, years ago, that was an accurate statement. It's not anymore.
And that's because of changes in the material, isn't it, Larry?
Yeah, batteries used to be made out of wood, and they just lined them with tar. And if you set them on concrete, yes, they would leach and draw moisture out of the concrete. Yes, they would go bad. I always tell people now with today's plastics, if you wanted, you could actually put a battery in a couple of bags of Quikrete. Ain't gonna hurt the battery. Makes it very difficult to change, but it ain't gonna hurt the battery. And then I always have a follow-up. Says, well, I set a battery on the concrete, 4 years ago and it went bad. It's like, no, the concrete had nothing to do with it. The fact it sat over there for 4 years is what caused it to go bad.
Yeah. And usually the worst case, you stain the concrete around it where you let the battery sit.
Yes.
It doesn't discharge it.
See if we have any other questions.
Don't see any.
And one comment made was, about the system is, we're talking about batteries today, but if you are doing your battery test, and especially if you have a write-up or a complaint for a charging or a cranking issue, batteries is always where you have to start. If your batteries aren't right, the testers won't even let you do the tests. But if you have a write-up for a cranking problem, I see it all the time. People go through and check the batteries. Batteries are fine. Must be a bad starter. It's like, did you check the cables? Why would I do that? You can have the best batteries in the world, the best starter in the world. If you don't have good cables connecting them, does it work? No.
No. That's something we've both seen on different fleets and with different companies, manufacturers even. Yes.
And that's one of those things I highly recommend. And I see one of our guests that's on today. He is one of my heroes because he is one of the best in the industry about doing pilots. That's where it all starts on all these things. That if your truck's not right when it's brand new, does it get any better? Obviously not. That's, you got to make sure the right batteries got put in the truck when it was new. You got to make sure when you replace them, you're using the right ones. But you also got to look at that entire system. Are the cables right? Are they mounted, correctly? The whole crimping, wire tying, all those things play a huge, impact in the life of that truck.
Yeah. Oh, here we go. One more. Do we recommend automated capacitance testers? Correct me if I'm wrong, Larry, but isn't that what our automated battery tester is today?
For the most part, yes. There is some other testers out there even more involved. I'm not, and I'm not sure 100% on the question being asked. But there is actual test equipment where you can actually do it's almost more like lab testing. That if you really wanted to check that battery, for reserve capacity and everything, you would hook it up on something that would accurately discharge it X amount and recharge it and look at how that battery performed. Probably the best thing out there, but you're talking a long time to test every battery. So you got to find that happy medium. But yeah, a lot of the electronic testers also are some of the capacitance or impedance where they are looking at that plate material at the same time.
Yeah.
See if we had any others. If not, we will wrap this up unless you have anything to add, Carl.
No, I don't. We very much appreciate their time and attention today.
Yes, thank you all very much. Tomorrow you will all get an email that gives you a link to the recorded version of this. So if you want to share it or whatever, and also, please feel free to give us any feedback. And if you ever want us to give you a report on your employees or friends, whatever, hey, how many of my guys have logged into this? We can provide that for you. So, again, we do this to help you as our customers and fleets out there.
All right. Well, guys, you have a great day, and we'll look forward to seeing you on the next one.
Thanks, everybody.